Hello, and welcome to this presentation on networking and connectivity on BlackBerry. My name is Sanyu Kirluda, and I'm a member of the Developer Relations team here at Research in Motion. This video aims to show you how to leverage networking capabilities within your BlackBerry application. We're going to go through an overview of the different transport types available on BlackBerry, and we're going to take a look at how you can best prioritize the networking options available. Walk you through some useful APIs for enabling you to choose the most appropriate transport type, and we're also going to cover the network diagnostic tool and some best practices for creating network connections for your BlackBerry applications. As you can see from this view of the network architecture, there are a lot of options available to your application, and this tends to make networking on BlackBerry seem complex. But we're going to step through each one so that you can have a very good understanding of how to use them all. We're then going to cover how to use the new networking APIs available in 5.0, which makes setting up network connections a breeze. The 5 transport types available on BlackBerry are TCP Cellular, WAP, including WAP 1.0, 1.1, and 2.0, TCP Wi-Fi, BlackBerry Mobile Data Service, and the BlackBerry Internet Service. All of these transports allow the creation of HTTP, HTTPS, socket, TLS, and SSL connections, except for WAP 1.1 and 1.0, which only permit HTTP and HTTPS connections. In all of the examples you'll see here, you'll see the use of the connector.open method to pass in a URL with appended parameters to specify the transport type. As a best practice, all connections should be executed on a separate thread so as not to block the event thread, and you should always remember to close all streams and connections and remove all listeners where applicable. Let's start with TCP Cellular, which we have in the past labeled as Direct TCP. The BlackBerry device connects to the wireless gateway, and then out to the APN, otherwise known as the access point name, and out to the Internet. The challenges as a developer are that you may need to specify the APN. That's why we recommend that you use BlackBerry Internet Service, BlackBerry MDS, or WAP 2.0 as your default connection types rather than Direct TCP. To use Direct TCP, you simply need to append the device side equals true parameter. If the APN settings have been hardcoded into the branding data on the device, or the user has set these settings themselves, then this is all that's required. If this is not the case, you need to follow one of the last 2 examples, in which you have to specify the relevant carrier APN. And in the cases where the carrier requires authentication, you must also provide the APN username and password. For WAP, the BlackBerry device connects directly to the carrier network and then out to the carrier's WAP gateway, which will then allow your application access out to the Internet and from the Internet to the Internet web server. It's important to note that there are 2 major types of WAP on BlackBerry, and they're leveraged differently from your BlackBerry application. The 2 types are WAP 2.0, and we tend to group WAP 1.0 and 1.1 as the other type, as they're very similar. To leverage WAP 2.0, we append device side equals true, and then connection UID equals XYZ, where XYZ is a CID of the corresponding service book on BlackBerry. You can find the appropriate service book by using the service book class and searching for WPTCP as a CID. For WAP 1.0 and 1.1, you must also append device side equals true, but instead of appending connection UID, you must append the WAP gateway IP, port, and APN that you're going to use. The reason for these differences is that WAP 1.0 and 1.1 leverage the WAP gateway, while WAP 2.0, although leveraging a gateway, is more TCP-based, and as such, there's less information that you're required to specify for WAP 2.0. In TCP Wi-Fi or Wi-Fi, on the consumer side, the BlackBerry device connects to a Wi-Fi access point directly out to the Internet and then out to an Internet web server. On the enterprise side, where the user has a Wi-Fi access point behind the corporate firewall, the application can connect directly to the company's Internet servers or connect back out through the firewall to the Internet. To leverage a Wi-Fi connection from your application, you simply need to append interface equals Wi-Fi, but this is not required when using BlackBerry MDS or BlackBerry Internet Service, since developers get Wi-Fi access for their applications for free in these cases. And I'll talk about this a little bit more in the next few slides. For BlackBerry Mobile Data Service, the BlackBerry device connects to the wireless gateway or through Wi-Fi and then out to the Internet, and then out to the BlackBerry infrastructure. From there, the connection is routed back out to the Internet, through the enterprise's firewall, and finally to a BlackBerry Enterprise server with MDS services. From here, the connection can either go to the Internet web server or connect back outside the firewall to an Internet server. As well, there's an option where the Wi-Fi access point VPNs in directly through the user's corporate firewall and attaches itself directly to the BlackBerry Enterprise server. The BlackBerry Mobile Data Service Transport is a secure, compressed, and optimized communication path between the device and BlackBerry Enterprise server. Using this transport type, and as we'll see next with the BlackBerry Internet Service, or BIS, developers get Wi-Fi access for their applications with no additional coding, as the device will automatically carry your connection over the Wi-Fi path when the user is in the area of Wi-Fi coverage. To make a connection using the BlackBerry Mobile Data Service, or BlackBerry MDS, in the most base case, no parameters need to be specified. This is because, for all BlackBerry smartphone models except for the BlackBerry 6500 series and the BlackBerry 7500 series, BlackBerry MDS is a default transport type when it's available on the device. To make an explicit connection to BlackBerry MDS, you need to append device ID equals false. This will automatically access the default MDS service book on the device. The last example shows how you can manually select the MDS service book that you want to use, in the case of there being multiple MDS services connected to the device. In this case, you specify device ID equals false, along with the UID of the service book that you want to use, similar to what we discussed for WAP 2.0 connections. Finally, we have the BlackBerry Internet Service, or BIS, where the BlackBerry device connects to the wireless gateway, or through Wi-Fi, out to the Internet, out to the BlackBerry infrastructure, and then back out to the Internet and the Internet web server. What is unique about the BlackBerry Internet Service is that it abstracts away the complexity of dealing with multiple carriers and APNs, so that you can connect through one consistent infrastructure directly to the Internet and your Internet web service. As with BlackBerry Mobile Data Service, you get the use of Wi-Fi for free. BIS also optimizes and compresses, but does not encrypt, all the data that passes between the BlackBerry device and the BlackBerry infrastructure as an added benefit to users. Currently, the BlackBerry Internet Service is only available to members in specific tiers of the BlackBerry Alliance program. If you're interested in accessing BIS for your application, please take a look at the information on joining the Alliance program on blackberry.com/developers. With an understanding of the different transport options available on BlackBerry, you'll need to define which networking transports are most appropriate for your application. I've included here a recommended priority list based on whether your application is geared towards the enterprise or the consumer. Please note that RTSP streaming is not available over BlackBerry Mobile Data Service or the BlackBerry Internet Service, and therefore your application, if it needs to stream data, will need to modify the above priorities accordingly. The new networking APIs available in 5.0 were designed to simplify the establishment of connections over the different transports available on the BlackBerry device, by abstracting away the details of parsing service records and appending the correct parameters to the connector.open URL. It can be used with HTTP, HTTPS, socket, TLS, and SSL connections. But please note that Connection Factory is not thread safe, and the call to get connection is blocking and should not be called from the main event thread. Additionally, the Connection Factory class provides many features to make setting up network connections easier. Developers can provide a prioritized list of preferred or disallowed transport types, specify connection timeout settings for WAP, BlackBerry MDS, and BlackBerry Internet Service transport types, and also enable and listen for connection retry attempts. In this example, it shows how to make a connection from a preference ordered list using the Connection Factory class and the networking APIs from 5.0. We will now turn our attention to some useful APIs that will enable your application to determine the networking coverage available. Coverage Info provides information on which networking transports are not just possible, but are in fact actually available to your application. Additionally, Coverage Info Listener allows you to listen for changes in the coverage levels relevant to your application. These classes cover TCP Cellular, WAP, BlackBerry MDS, and the BlackBerry Internet Service transport types. To determine whether Wi-Fi is an available option for your application, or to listen for Wi-Fi coverage changes, you can use the WLAN info or WLAN Info Listener APIs available since version 4.3. But remember, these are not necessary when using BlackBerry MDS or the BlackBerry Internet Service transport types. The Transport Info class and the new networking APIs in 5.0 provide an even simpler way for the developer to query both the availability of transports on the device and whether a specific transport has sufficient coverage, as shown here. And the Service Routing API allows the device to detect least cost routing either through USB or Bluetooth connections with a desktop computer. There's an excellent KB article on service routing that provides detailed information and sample code that can be found by searching for service routing in the developer knowledge base at blackberry.com/developers. Once you've started using the different transport types for your application's network connections, if your application is still not connecting as you expect, the Network Diagnostic tool can provide a simple agnostic way for you to verify which transports are accessible on your device. If the Network Diagnostic tool cannot connect to the relevant transport, you should verify that the device is properly provisioned and has appropriate coverage. But if the Network Diagnostic tool can connect while your application cannot, full sample code is provided and can be used as a reference sample to compare against your own code. This tool is free and can be found in the Developer Knowledge Base by searching for the Network Diagnostic Tool, or NDT. To wrap up, here are some networking best practices that I'd like to leave you with. Understand, choose, and prioritize the most appropriate transports for your application. Always execute your network connections on a separate thread and clean up after them when you're done. I'd encourage you to utilize the new easy-to-use networking APIs in 5.0 and to download the Network Diagnostic tool to help you verify and test your own code. Thanks for watching and have a great day.